In this video, we'd like to present results from our work on ResiVis, a novel, holistic, underwater motion planning approach for robust active perception under uncertainties. To start with the simulations, on the left side, you can see the aquaculture baseline for comparison, and on the right side, the ResiVis proposed approach. As it can be seen, in the static environment of case 1, the baseline, by using a fixed observation distance and clearance, makes more risky and aggressive decisions to inspect the structure, while ResiVis, by monitoring the situation and exploiting the variable observation distance, displays a more safe, efficient, and adaptive to conditions behavior. In case 2, that involves a large dynamic obstacle moving against the current, aquaculture suffers from collisions in the attempt of inspecting the moving wall, while ResiVis is able to inspect it with safety, adapting to unexpected changes in the direction of motion and against the current. Case 3 consists of the cluttered environment with moving obstacles, shown with green, and dynamic obstacles shown with red, executing random paths. The baseline operates in proximity towards the direction of the moving objectives and collides both with dynamic obstacles and objectives. On the other hand, ResiVis shows superior performance, navigating safely through the environment, adapting to the measured motions of the proximal dynamic obstacles, while also maintaining visibility of the nearby objectives. This experiment also shows that the ResiVis framework scales well with increased number of dynamic obstacles. To conclude with the hardware-in-the-loop experiments tested ResiFarm performed in one of the fish farms of the Sinte facilities, case 1 involves inspecting a static structure. As can be observed, ResiVis not only quickly adapts its clearance to the perceived conditions, but also showcases its robustness to high instantaneous localization errors of more than 1.3 meters, as can be seen at around 75 seconds. Although it reaches close to collision, it maintains safety, proving further the safe but non-conservative obstacle avoidance policy. Simultaneously, ResiVis enables the robot to constantly observe the target structure with respect to orientation and distance, with the exception of the aforementioned situation. Case 2 showcases the capacity to avoid dynamic obstacles, shown in red, with localization uncertainty, while maintaining visibility with static green objectives. This indicates the important emphasis on safety over perception, along with shortcomings of the technique related to occlusions. Finally, case 3 shows an example of avoiding dynamic obstacles while also attempting to track moving objectives. It is worth noting how the path is adapted to perceiving the future projected positions of the green objective, while maintaining safe distance from the red obstacle. Regarding the later point, ResiVis displayed strong capacity to track moving objectives and avoid dynamic obstacles in collision track, while simultaneously experiencing significant localization errors. Thank you for your attention.